Thank you very much, everybody, and thank you very much for joining me on a morning after what would have been a good night partying as well, because it's good out here. Okay, so what we're going to cover today, I really call it our mountain to climb. At the moment, in labs and our industry is going through massive disruption, and we have got a lot to tackle. So I'm going to talk about the digital transformation, how we're going to utilize it, but I'm going to share with you at the end something that's going to completely change the whole dynamics and could even mean the end of chairside. This could be huge. So, I'm Steve Campbell. I am very fortunate that I sit on several boards. I'm an educator, I'm a fellow of the College of General Dentistry, but actually, this is the thing I care about the most. I'm a dental technician first and foremost. I absolutely love the job we do because we transform people's quality of life. We work with our surgeons. You see, we transform people who have no confidence, no ability to eat. They go out, changes their lives. They normally then get a divorce. You know what I mean? They get all the self-esteem back, and then they bin off their partner and start again. So, little quiz. We'll see if we can wake up this morning. What do all these have in common? Well, the answer is they're not what you thought they were at first glance. And that's what we do as actually dental technicians. We fool the public. We don't make teeth. They've lost teeth. We make prostheses that look so good you'd believe they were teeth. And it's nothing new. This Egyptian mummy, when their remains were taken up, this was a fake wooden and leather toe that she had because she didn't want people to know she was missing a toe. But this is only a cosmetic, aesthetic restoration. We actually make medical devices like this. We restore form and function first. The aesthetics is the party trick. We have to do that to cover it because we're not lucky enough to work in just doing like hip grafts and stuff like that. People see our work all the time. But we are working with medical devices and restoring people's smiles, and we have been doing an amazing job for many, many years. And the question I always get is, well, you keep banging on about digital, Steve. Why change? I've done a great job. My lab's well set up. Why am I going to change? And to know why we're going to change, we've really got to go back to when these were still being utilized and our dentistry was in this era. So in the UK, dentistry as a profession is only just over 100 years old. It's actually quite a young profession. This is dentists. So they were brought in under the GMC. Technicians followed not long after, 1948. This is our Minister for Health, Anya Bevan, and it's a global joke. Everyone says the British have terrible teeth. And we do. So much so that it was a state of emergency, and we had to train a lot of surgeons and technicians to help improve our nation's health. And these were thousands and thousands of dental technicians we were training at our institutions in the UK. Thousands of highly competent, some of them still working today, with the best skill set that you'll see. And these were all of the schools and colleges that you could go and train to become a dental technician in. But as of last year, these are the only ones left. We have a real crisis in the UK. We only put out 98 dental technicians last year to go to 1,500 labs. That's hard to get hold of a good dental technician. But I'm more worried about this. Our schools are still teaching like this. So you saw at the Bunsen burners and the stuff at the beginning, they're essentially still teaching the same thing. Okay, she's lucky, she got in sewn and she stole the electric wax knife, not the Bunsen burner. But actually, it's not fit for purpose. We have the other side of the scale. This is the number of dental technicians in the UK. We now have under 5,000 to serve all of the UK's needs, which is absolutely catastrophic. But look at the dip. And we know we're going to lose another half of these. How do we know that? Because we know the data, and we know that the average age of this group is 58. That's their average age. So when I was the president of the DLA, that's the only Christmas party I looked young at. Not so much anymore, not so much anymore. But here's some really good news. We are in a massively growing industry. The demand for, this isn't dentistry, this is dental lab services. It is exploding. There is no better place to put your money right now in investment is to get a lab, set it up, because you are going to make a killing. But all of these groups have all focused on the same problem. They know we're going to have a skill shortage. That's our limiting factor. And all of our surgeons, all of our team are struggling with time. They're really busy. So their perception of how busy they are is continually increasing, and their stress and load. So when you look at these two graphs, and I'm not a big fan of graphs, but this is the growth in demand, and this is the decline in technician numbers. What does that look like to you? Looks like a time problem to me. I've got a supply and demand issue. I need to fix that issue. So I get on really well with my surgeons. And when I told Tim my problem, he said, well, Steve, just work harder. I was like, cheers, Tim. He said 7 days a week, 24 hours a day, just work harder. I was like, okay, fine. Can't work any harder. We can't work any harder. And I'll be brutally honest with you. The technicians that I'm employing now, the young professionals we're bringing on, they don't want to slave like we used to. You know, I did do stupid hours. That was the culture. They don't want to do that. They want a work-life balance, and they deserve it. They should have it. So when we started Nexus 10 years ago, we kind of did this. We took a step back from everything. I left the lab, and I thought, if I'm starting fresh, am I going to copy the old mistakes? My answer was no. So we looked at everything we were doing. So the tools had to be better for the future. We went digital, day one. That was it. We were not going to do any more casting. We weren't going to be doing any of the gold cast. I saw you with your picture with your flame torch yesterday. Yeah, I used to love those until it goes bang when you turned it off and you jump out with your skin. I did all of that, but we weren't going to do it anymore. We had to be more productive. Of course, my technicians can all wax up. Of course they can. CAD-CAM is a tool, like your wax knife is a tool. It doesn't do it for you. Some of the worst work I've seen is digital work, because unfortunately, the people doing it don't know what they're doing. They don't know how to use the tool. These technicians with these skills now transfer those skills over into digital workflow tools. So we take this case for Martin. Implant plan for the central and back on the molar. Easy with Exocad. Biogeneric flip copy, pop them into place, and now I can share that with my surgeons. Anybody here using Exocad? This dental share feature for me is one of the best things for saving us time and hassle, because when I click that and send it, I'm tapping into the first benefit of digital workflow, which is enhanced communication. What do I mean by enhanced communication? Why is this better than our old way? Well, if you look at Abraham Lincoln's statement here, it's totally true. Anything you write down and store will span space and time. It's there for generations to come. I dread to think what my great-great-grandchildren are going to see from my pictures of Facebook and Instagram and all of the stupid things I've done, because unfortunately I am at the age where I'm capturing all the stupid things I'm doing. I wasn't like my parents who were too soon for that. I'm leaving this digital trail of being an idiot. So this written communication is great, but it has one major flaw. How many times have you got a text message or an email and you read the tone of that completely wrong? I've done it loads. I've read it and I thought, screw you. And it wasn't meant that way. But here's the other thing. It's actually very easy to misinterpret the message that's being given to you. Okay, this is poor grammar. But it seems like Rachel Ray finds inspiration in cooking her family and her dog. Family's gone. Dog's looking worried, because that's the next one in the pot. So it's easy to miscommunicate in just a written term. So I have a little dog story of my own, and I'm not proud of this dog story. So I was in Norway, I was flying back, and my wife rang me. So talk to each other, it's got to be better. Yep, fine. Said, we're going to get a dog. Been talking to the boys, it's time we got a dog. Complete the family. I was like, absolutely. I love running, and I live in the Yorkshire Dales, and I grew up with Vizslas and Weimaraners, and I was on that plane visualizing my new life with this beautiful beast. I got back, she put me in the car, and she took me to see the breeder. And this. And I was like, that's a chubby rat. That's not a dog. You said dog. I absolutely am not the kind of guy who would, normally be this mean, but I just put my foot down. I said, get in the car. We are not getting that animal. Let's go. Well, let me tell you, my wife does not listen to a word I say. But genuinely, we've been married 21 years now, and you get things wrong when you're left to build your own mental picture. So let's not do that. I share exactly what I'm going to do for my surgeon. They can open it when it's convenient to them. They can look at it from all angles. They come back and say, That's exactly what I want, Steve. Let's go. So really time effective. Only then will we do the model. So we haven't cast the model, done the wax up, get it in, get an adjustment. Massively time saving. This, if you get a chance, go to the XCAD booth, because we have started to do this now. This is the next level. We're going to do the wax ups, but we're also going to do these true smile videos. So you're seeing a before and after for this patient. The genius of it is, it's both before. It's generative AI that's making this image, but it's made from a real design. It's not some fake made up, we can't deliver it. We can deliver it because we planned it as technicians. So the lab's involved, not some stupid app that promises them they can expand the buccal corridor by 10 millimeters, because you can't, the gum's not there. This is something you can make. You've got to go to Exocad and see this. And the simple fact of the matter is, visual images, we retain the information a lot better. Our brains are wired for better visual stimulus and information. That's why we do a better job of communicating around a visual object. So let's look at how we do this. ELOS scan bodies and a scan. Coming in from a very good friend of mine, Dr. Martin Wanadea. But look what he's done. No miscommunication here. This is where I want my tissue to be moved to. This is where I want my incisal edge to be moved to, Steve. Perfect. Give it to me simple and I can give you what you need. But there was a problem. We've hit this many times with many brands of scan bodies. Tie bases used to have issues. They were getting too wide. More and more, Min mentioned it this morning, the more modern implants are all going deeper subcrestal. So the incidence of bone binding is increasing massively. And a lot of the components were never designed to encompass this feature. So what were my surgeons doing? They were butchering scan bodies to have to compensate for this transition and change. This has been a part of a sort of a new wave of thinking about implants going deeper, more Morse tapers, go subcrestal. But you don't have that with the new scan bodies. So the new scan body 22 has this one-piece design. Look how narrow and fluted it is. It allows you to avoid the bone engagement issue. And also, this surface is very important because you're getting a super accurate scan. And you don't have to go and now get whole new fleets of libraries and then which scan bodies you use, the old one or the new one, doesn't matter. You can still align it with the same library. That's important. I hate it as a laboratory when surgeon sends me some new scan body I have never seen and we've got new libraries, some new weird out there componentry. It's got to go because it actually hurts the lab's productivity. But this scan technology you're seeing here means that it doesn't suffer from as much of the scatter you see on these other surfaces. And that doesn't look like it's huge, does it? It's not massive scatter. Is it such a problem? This? Does it matter? It does matter. Because this is what we really see in the lab. Scans like this. And then when we bring the library file in on this competitor scan body, you know, is that an accurate enough mesh for me to make an implant crown? Not really. But we have to, because they're not going to rescan it. You know, you ask a surgeon to rescan, oh, I can't. Patient happens to come all the way from Scotland. They travel 3 hours to see me. No, they don't. You know what I mean? But there's always an excuse. So we are suffering with this. This isn't a true alignment. When you do it with the scan body 22, it's an accurate mesh. If you do get deviation and misalignment, this is what you end up with. Occlusal or contact issues. Now then the surgeon gets a little bit frustrated with you because this sort of 5 to 15 minutes adjustment time actually is incredibly expensive for a surgery. Like 500 to 750, which is a billable rate in a UK surgery, it will cost them in those adjustments 125 or £187.50 in lost chair time. They could have seen another patient. You get 5 adjustments in a day, you've lost a full appointment. So my surgeons don't like it. And then they ring me, and it's somehow my fault, even though I sent them a screenshot saying, your scan's not very good, would you like to rescan? No, it'd be fine, until it's not. But interestingly, if you look at this, so I've got a lot of QR codes, and I do speak fast, I've got a lot to cover, so you can have the PDF at the end. But if you go to this study, you'll actually see they were looking at just scanning accuracy, but it was the ELOS scan body that performed the best in this for accuracy. So if I'm going to deliver a crown that needs less adjustments, I've got a happier surgeon. Absolutely a win for me. Because we're going back to this. Does anybody have this book by Makoto Yamamoto? Yes. I still make my team read that book. It's still relevant today. 1975, that book came out, but he had it bang on. You should always do the full contour, strip back just for what you need. But I can't do that because I've got a limited time. I can't have a team waxing up all day. I can't afford to pay them to do that. So what do? We do it digitally. The full crown, the ideal cutback, the ideal abutment, custom if you need it, and then obviously the analog in there. Because I want to avoid this, okay? And I'm not anti-tie base. I'll make it really clear to you now. I'm not anti-tie base, but I do remake a lot of cases like this. Does anybody want to have a quick stab at why that's broken? 100%. 100%. Cantilever loading. So the occlusal force is coming down here. You're cantilevering your load, blows it out at the back. That's a simple mechanics, physics thing. We know this. And if you look at it through FEA, and obviously Casper's in the room, so I'm going to be very careful here, because I'm going to get caught up on any technicality immediately. I'm not as good as Casper on this. But even at the studies they were doing, or just on materials, they were finding that anything where it was too tall, the lateral forces that Min talked about earlier, this is where the stress and load comes out. This is where we see these things blow out. I don't want that, because that is going to be an issue. Min also mentioned this. This was the Holger Ziprit study, which is to do with the fact that we get lateral load on our teeth. We're not crocodiles. It doesn't just go up and down. You get lateral load, and that's where the load on the material or the screw comes from. And yes, zirconia is great in volume. Look at it when you take it from 1.5 millimeters, where it's got a great amount of strength, and just by bringing it down to 1 millimeter, halved its strength. Now, where are these things the thinnest? Right down there at the base. Normally, we're trying to get away from the tissue. Lyndon Cooper's also been doing a study on this at the moment, and that's not been published yet, but we're now starting to understand. Guys, it's mechanics. You can't get away from it. So if I see something like this, it's just not a tie base for me. So then I advise the surgeon to go to a custom, because I didn't have a better option. And I don't want to be dealing with all of these issues going forward. So I needed something better. So it would be a custom solution for me. With angle correction, this is what I would be designing. And if you look at it, why am I wanting to do these? Well, Min talks about this as well. We've got to deal with the biologic width principles as well. This is where the bone engagement risk is the highest, so we don't want to go wide here. Then we flute out to the transition zone for the crown, because we need to have that good tissue emergence profile. That, for me, is the ideal. That's what I'm aiming for. We've got it now with a HB4 or titanium base EV. That is exactly what we now have. Very narrow emergence, no bone engagement issue, but look how high that chimney is. That's a big chimney, but that's not his best thing. Its best thing is this. It's not just one set chimney, it's 7 solutions in one. 4 gingival heights to compensate for them, but this angle cut was genius. I remember when Casper sent me across this thing, we've got this idea, what do you think? I was like, I would buy it now. Yes, I deal with this all the time. So let's look at a real case scenario. So this is a competitor's tie base that we were using in the past, and I'm not here to slate companies, so I'm not going to name them, but it has an issue. That's quite wide. And you've got a lot of sort of body coming up there. The blue is how much thinner the new HB4 base is. So I want that to be narrow in that emergence area. You can see this transition from the old one to the new one. Look how much narrower it is. That's a lot better for me. That's the area I want to keep it thin. But the other issue for me was this competitor base in its longest possible form, that's the most I could get. So that's still got way too much high load for me. You don't have enough to compensate for the torsion. No solution. HB4, on the other hand, with the angle cut, we put it in, we get this. So we're getting a good high stability, taking the stress away from that base. That's exactly the same case with the HB4 in with the angle cut. Absolutely perfect. Takes the volume I want and also allows me the ideal support. Look how clean and narrow it is and the way it develops out. This is exactly what I do with custom abutments all the time. Now, if anybody messages me after, I've actually got a PDF link to this, an active one, so you can open it and you can move it around. Because look at the analog as well. That's a rubbish analog. Tiny little analog like that for all the work we've been doing. How is it going to be accurate by the end? You do want a more stable, accurate analog. So these are the customs I was making. That's the HP4 I'm making. And I'm going to show you some of those cases. We comply with the gingival biologic principles as well, because we know now, with a lot of the data coming out, that really going deep subgingival, it's zirconia, clean, polished zirconia, no glaze, no ceramic, and titanium. Tissue loves it. So that's what we're aiming for. So when we make our normal crowns, this is on purpose. I had surgeons ring me say, why is it just white under the tissue? I was like, because it's just polished zirconia. I want the tissue to adhere to it for you. We do that with the HB4s. This is the HB4, and that area there is not glazed at all. So we're carrying that transition on. We want that tissue seal. If you seal, you don't get the risk of any bacteria going down to the implant site and then like bone recession. It's an absolutely gorgeous design, and look how thin and high we've managed to get it, and they are color-coded screws. So if you're using it in the titanium-based version, you get the color-coding screw. And we already mentioned that we're also definitely trying to avoid bone engagement, because if you get bone engagement or you get too wide, too close, the bone disappears. When the bone goes, the tissue goes. The tissue goes, you're getting a phone call from a surgeon upset, because you can see it immediately. When someone asks me to play the game of, and we're all technicians, so we do this, someone shows you a thing and they're like, guess which one's my crown? I never normally can pick it by the ceramic work because it's really good. I just look for the gum line and I'm like, it's that one. Well, how would you tell? That crown's amazing. It's like, yeah, it is, but the surgeon's got the tissue all wrong. You know what I mean? So that's how you know. You're not going to have that issue with this. So, and again, I have taken the names off because I'm not here to slate companies, but this was the competitor that we were using, the best we could find, you know, for our needs with Martin. This is the complete redesign. And they listened and took on board when we were saying, no, it has to have this negative S-curve. We know from all of the cases we've fitted how much better it does. And I can now have angulation, but because of the angle cut at the front, I don't lose the height of the retaining body. Why? If I do lose height of retaining body, I'm reducing surface area. If I reduce surface area, I reduce my bond. More chance of debonding. This study here, if you go to it, it's exactly what they looked into. So these smaller angle-corrected bases, higher rate of debond, which makes sense. You don't have much to bond to. Now, there's only one technician in here from the UK, isn't there, Jamie? Just you. There's no other technician from the UK. I'm still waiting for the technician to come and punch me. So in a support group in the UK, well, it's not, it's on Facebook. You shouldn't post it on Facebook. You put, morning all, had a couple of these recently. What can possibly be going wrong? Occlusion's fine, the doc says. I'm like, what? I mean, just look at the ratio. Of course it's debonding. You know, like, what do you mean the occlusion's fine? Do they just drink soup? Because if the minute they eat something, they're in function. Weirdest thing. And then they were like, oh, it's just bonding. It's a bonding issue. And I was like, well, actually, that is an interesting topic, because Casper here has been very good at drawing me in, because I thought we were a really good lab until Casper came along and burst that bubble for me. So he invited us to be part of this amazing study where they sent out a lot of their components with some zirconia already and said, we just want you to cement those 5 pieces as you normally would, send them back. And we were like, yeah, this is going to be great. He's going to be so impressed with what we do. We're going to win. No, we didn't, because we were stupid. When you look at this surface and you're going to bond to it, what's your first instinct in a lab? What would you do? I'm going to tell you straight away. We used to sandblast them. Why? Rougher. Rougher's better. Yeah? It is, isn't it? You're not going to cement to a shiny cap like that, are you? Anybody in here going to cement to that shiny cap just as is? No. Turns out we should be, because the minute you sandblast them, you massively reduce your bond strength. Who thought that? So turns out we were near the bottom of this class. I was getting the D hat at the end of this particular test. I just couldn't believe it. So do go to these studies, because what you're doing actually, it's an engineered fit. And Min talked about this. You're actually increasing that, which means it's more chance of debonding. We don't want that. So that was great. I'm not just getting great products, I'm actually getting told how to do my job better. Yeah, that was an interesting day. So there's a lot of interesting stuff coming out here, but when you work with ELOS, they actually do look at every element of it. They're not just saying, oh yeah, we've got a base, oh, well, we've got a base too, you know, and it's cheaper or whatever. That's not the mentality. It's a whole ecosystem of support and improvement, because this is what will kill your lab today. Remakes and adjustments. You cannot afford to do a job for nothing. You can't. I don't know what the average salary of a technician is in the US, but in the UK now, if you want a good, highly skilled technician, it's going to cost you £50,000 to £60,000 a year. And it's going to go up. It's going to keep going up because they're getting rarer and rarer. And you know what? Good for them. We should earn more. So we can't afford remakes. So I need to eliminate all of these debonds. And it's not good for surgeons either. So when a surgeon niggles with you over 50 quid, no problem. But I know your chair time's 500 to 750 pounds. So if that then debonds, or if you have an issue and it's taking you an hour, you're 750 quid out of pocket. That 60 quid was a false economy. So it isn't about that. And we have this conversation with our surgeons. We're very honest with them. I'm like, I could give you something 60 quid less. You're going to hate me in 3 years for it when you're wasting more chair time and getting back, because I've told you, I document everything. If I talk to a surgeon, I send them a follow-up email and we save it to file, because I just know from experience in 3 years, like, oh yeah, this thing broke. I'm not really sure why. I'm like, oh, because I sent you this email and we told you it would break. So now we're going to charge you again. How'd you feel? You've got to do it, because it's the worst thing, because you know, you do that much work, you normally used to forget. So I make my team do all 3 emails. So how does it look? This is Martin Wanadea's case with the HB4. This is just such a beautiful design. It's doing exactly what I would do with a custom abutment. Go to fit. I mean, he makes us look good. It's a great solution for it though. And what is great about that? That's all on file. So as that heals and matures, and he rings me up and says, it's perfect, I'm not going to do anything again. I'm going to bring up the same case and now just mill it in zirconia. I'm going to bond it, I'm going to send it. He's going to remove one and put the other one in. So there's minimal engagements and disengagements. I'm maximising his chair time. I've saved him a whole chair time session. Like, thanks, Steve, you saved me 500 quid. He didn't say that. He never says that. He never thanks me. No, he does. He's a really nice guy. But look, what was I telling you about deep bone engagement? They're being taught now to put these implants deeper and deeper. So it's going to be on your radar. I actually ask for x-rays now when we're getting scans in. If I know it's a deep subcrestal implant, I say, look, can I please get the x-ray for that? Because I need to know where I've got room and where I haven't got room. But sometimes, even as good as the HB4 is, you ain't going to cut it. It's not going to work. You're going to have a full custom solution. Like, look at that. There's no way getting anything on there. So what do? It's not a problem. I mean, over in the US, you guys have got Vulcan. We've got SkillBond in the UK. And what you can do is, because it's an open library system, you can do your design, have a OEM part, FDA 510K cleared, and have it machined. Great. So you don't have to stick in just one thing. You can switch it over and do this, because you wouldn't believe the amount of implants I get like this. I mean, it's so distally placed. So this isn't good for a base. No problem. It's a custom abutment then. Any lost custom abutment, go through Vulcan, get it. Because I want the zirconia to sit passively on the stronger titanium that can hold that cantilever load. Then this slightly weaker material, all it's doing is just sat there passively. It makes it a lot easier. I don't run a milling machine, but I'm pretty sure it doesn't happen that quickly. We've never run a milling machine because we just are lucky we have other partners. But this is the benefit of it. We make a lot of these sort of cases. So somebody did mention earlier on, they were talking about OEM. You know, I don't know if you guys had it over here. We had it in the UK. It was called original on original. Is it a term that's been used over here a lot? No? So it was original on original until the company bought a company that made lots of copies. And then they were original all of a sudden. So I was like, all right. So, right. But I couldn't use those last year because they were rubbish apparently, weren't they? Oh yeah, it's different now. Well, yeah, what did they do? Retool it all? No, we bought them. All right, okay, fair enough. So just magically improved the quality of everything. So original on original, great. But it's an end-to-end system. So it's the milling holder, it's the whole tool and kit because they're going to give you full validation. So everything from design through product, through the way it's produced, means that you can keep it and get full FDA approval. 3Shape or Exocad, we design them on. I know InLab's actually quite big in the US. Are people in here using InLab? No? What's the biggest one here? Is it Exocad or 3Shape? 3Shape. 3Shape. It's still 3Shape's the biggest one here, yeah? So you can design all of these, and then you look at this holder, and you're like, because I looked at it and thought, well, why are you making a holder? Because they've got their own holders. But it's that attention to detail so that when they do it, it's locking into exactly the precise position every time. Because if you're going to do split files where you're going to send your crown off to mill and get your abutment milled, you just want them to go together perfectly, don't you? You don't want them to have any kind of slack or movement, and that's what they're addressing. So it's a whole ecosystem, everything covered, everything validated, fully supported, and again, you can get your libraries directly from them, or you can get them from Vulcan as well. I touched on the analog earlier on. These really matter. They really, really matter. I hate that little analog I showed you before, because the amount of times I've looked at a job that's gone all the way through the lab and got to the end, and I see a technician having to take them on and off, and then they have to get a model reprinted because of that high load. It started to become a bit loose. So we have a new model printed to send it out. So it's cost me 2 models because of a rubbish designed analog. This is completely different. Printed models, I've got 15 3D printers. I'm a huge fan of digital dentistry, but printed models are not great. They're not. You know, I came up on stone models that were highly accurate. Everything was very reliable. Printed models aren't. And one of the things that you see, when you see people putting analogs in printed models, they put it on a desk and then they push it down from the top, don't they? Push it into it. So you're putting all that stress onto a model and potentially deforming the thing. But you don't do that with this because you've got this special tool that goes in and pulls it down and locks it into place. So you're not putting force across the whole model. It's very controlled and localized, and you've got a locking screw, which is important for when you're doing larger cases. And we'll come on to some other bits later on. But this for me is incredibly time efficient. And where do I want the most time efficiency? On my large span cases. So again, you guys have got Vulcan over here, so you could do your designs. Yes, you can do split bars. I've heard a lot of people talking about that, and I'm going to show you a split bar and why we couldn't use it. We will do our designs in PMMA, or now, you know, there's a lot of very hard, it's Crown X by Straumann available in the US. Has anybody seen it, a printed material? Wow, it's strong. So what we're now doing is, we're taking these immediate load restorations, our surgeons are scanning both sides of it, and then what we're doing, I'm not going to show you him scanning it, we're bringing all of the information in with the scan bodies, and very soon it's going to be ELOS, I believe. We're going to bring those all in, and what we're seeing actually, with certain scanners, we actually are seeing some really good cross-arch accuracy. But bear one thing in mind, a lot of these aren't talking about one major problem in our industry, user variable error. The user makes a massive difference. I've got 2 surgeons, and I'm going to show you a picture at the end, both got the same scanner. One of them does amazing work with it. The other one looks like a landmine's gone off. I don't know what I'm looking at sometimes. But, you know, obviously Mark Ludlow here has got some great videos on how to get good, accurate cross-arch scans. Here's a case from Stefan in Belgium.
Steve, can you go back to that scan bar that you had this scan?
Which one? This one? Yeah. Oh, to get this thing? Yeah, of course. That's a great video. That is a great video. You're welcome. Okay, so patient come in. We're going to do a scan. This was their original teeth in the blue. We're going to try and correct that. We're using the Smile Design suite in Exocad to do this because I like to send that 3D viewer I told you about. And this chap's in Belgium. We're in the UK. He's across the channel in Belgium. So we've got to be really efficient in our workflow here. And then I'm not here to sell you any of these resins, but there are a number of resins you could use to print these try-ins, because that's what we do now. we print them. And we actually do use this material. I have never seen a material so hard. It's incredible. And you polish it up, it looks really good. And it kind of, this is it. We actually use it for singles. You know, just like, what do you call them? Flippers or just we use it for that. And, oh, touch wood, not one of these is broken. And that's a thin connector that's sort of carrying that into. So that's just a polish, very minimal work, goes out the door. So we do the setup. We want to get all the tissue contouring right. So this was the printed try-in that we sent over to Stefan. And the reason that we always do the printed try-in is because I want him to be able to adjust it. And that's exactly what he did. So over a few sessions, he increased the tissue pressure to where he wanted it to be, made a few adjustments to where things were going to happen, and then recaptured it all in a scan for me. I brought it back in when he's happy. I bring it back into my software, and I overlay it onto what we'd done before, and then we make the new adjustments. So he doesn't send it back to me. It's a one-way journey. I send that printed try-in out to Belgium. I never get it back. I never see it again, because we're trying to cut down on backward and forward shipping, because it's quite expensive to send in and out of Europe at the moment. So you can see the change it actually made. There was quite a lot of changes going here. Now, I normally send all of my large span bridge cases up to Dentsply Sirona for the bridge base. So that's exactly what we did. We took all the information. They contoured me this lovely bar that now sits and follows the tissue contours perfectly. And I looked at it and I thought, oh, great, we're on a winner. Let's get this off. And then I looked at it from the front. This is the ideal patient approved, and that's the minimum thickness they could make the bar to. And I was like, oh no. So when I merged it, I've got this. Now, I wasn't going to make it, promise. I sent it to the surgeon and said, what do you think? Do you think the patient's going to go for that? Well, they weren't impressed. They were like, no, Steve, they're not going to go for that. And I was like, well, actually, you're really lucky, because we did this with ELOS. So what am I going to do? It's an open library. We can't do the bar. We've explored that at no cost because we haven't had it milled yet. We're going to use these. And he was like, perfect, let's go for it. So now, because we switched the library back to these, look what I could do again. I could bring it all back in. So I wasn't stuck. We didn't have to have that really awkward conversation, and I didn't have to get the patient to accept their teeth coming forward. Here it was out of the mill. This really white layer here, that is on purpose. I'm not here to sell any products. I'm sure there's other products do it, but we find this really handy if you want to block out the grey or gold coming through, because it virtually no cover at all, and it goes in with a sinter, but it gets rid of this greying. So it really works well for you. So this is it finished, and then those are in. They're not bonded in. There's a reason they're not bonded in. I've done it all digitally. So if you'd got to this stage, how would you now finish this? Because there is no wrong answer, you know, because I've shown you I mess up all the time. But if you're ready to go, would you cement these here yourself? If you've done it digitally? No. And we didn't either. We spoke to him, and luckily, Stefan's a very skilled surgeon. He's like, he's really used to intraoral bonding. Pick up and bonding, he said, not a problem at all. Send it to me. Why do I want him to do it intraorally? Pardon?
Tolerance stack.
Exactly that. Exactly that. Love your jacket. So it's exactly that. It's tolerance stack. And I know that I'm not going to get that passivity. He absolutely is. There's a intraoral and plaster model, but here's the key. Plaster model, not printed models. Don't do this on printed models, because it's exactly what the gentleman at the back said. It's the error stacking. You've got the capture of the data, then you've got the printing of the model. So if you try and, you need a picture of that? So if you try and then bond onto that, you overlay the original file to the printed file, they're not there. And we see a lot of 3D printers. I wouldn't trust them to do this final bit. So, ELOS again. And we weren't part of this one, I don't think. I don't think we printed any models for you this time. So we didn't get a D on that one. So you'd normally do the cement on the model. We know it's passive, it's all verified. The Sheffield test, no lift, no stress. Great. So they took this finished bridge, but then they put their scan bodies on, captured it, and then they sent that out to have models produced, printed models produced. And this is just a small selection of some of the ones they got back. Well, wow, okay, you know, I wouldn't have even sent that out the door, I'm not going to lie. You know, I wouldn't have sent that to someone, it just doesn't look right. And obviously, you didn't use this one, because you're not going to be able to get any accuracy there. And look at the gap size when they do put it in. So we know the bridge is accurate, we know that bridge was right, but this is what happens when you create a 3D model from that bridge. You're not getting the accuracy. The problem's in the model, the pre-printed model. Now this is an actual medical print company. You'd think they'd absolutely nail it, but again, they've got that gap. How bad is that gap, do you think, clinically? Think it's going to cause you problems? Yeah, it's going to cause you big problems. Because you wouldn't think that gap would cause you 45 kilograms of screw force. That's insane. So what happens then when you get that much force? Now I do know the technician who sent me this. They are a very good friend of mine. This was straight out of WhatsApp. He said, look, morning mate, this has just popped out. What do you think we're doing wrong? And I was like, is it digital? Like, yeah. Did you bond it on a printed model? Yeah. I was like, that's what you're doing wrong. He was like, well, what makes you think that? I was like, because it won't have been completely passive. He was actually lucky that all it did was just pull it out of the frame. Because if it hadn't pulled it out of the frame, the stress would have been in the frame, which leads to this. Catastrophic failure. Because it's going to build up that stress over time. On the day, I'm not here to sell it, it's just what we now do. We actually do, if we do immediate load days, we make a metal connected jig. We then create a model, so if we do want to bond it in the lab, we'll put it on that. We'll bond it on a connected metal jig model. Then I'm happy. I will not do any other bonding in the laboratory unless I've got a solid metal jig. So what are we doing here? We're trying to avoid the time hassles for the surgeon again. We keep coming back to this time being our potential issue. But if you utilize all these new tools and all of this new stuff, you're going to unleash your potential. That sounds like a really cheesy thing to say, doesn't it? Sounds like we're in one of those, like, whoa, seminars, yeah, unleash your potential. But you don't want to be like a one-man band. You don't. What we do best is we operate best as part of a team. This is fine, but this is the things that we kind of remember. These are the moments that blow you away when something's done to scale, and it always takes a great team to do it. We only have a small laboratory, especially compared to you guys in the US. You know, like you guys have, wow, some amazing, huge labs. And we're in Ripon, North Yorkshire. We're literally in the middle of nowhere. So this is the Tour de France, and they brought it over to Yorkshire because we have such challenging terrain. If you go 15 minutes from my lab, this is where you are, genuinely. So, you know, I have a lot of sheep as friends, and that's about it. But it doesn't really matter, because even though I'm that remote, I am actually part of an amazing team every single time I walk in. This is my team, and this is obviously, Simon's not here, but Simon's from Skillbond, he's our UK group. But these guys make it work, and there's that dog that I didn't want. Now I have to take it to work as well. But we're part of this global team every single day. I turn on that computer and I've got all the engineering backup and support from Casper and his team. All of the lessons that I've been, given have been from this guy, remote. When I first started as a technician, you relied on a rep that came in to see you once every 3 months, and that's pretty much all you got updated with. We get great support these days. And guess what? They're not a flash in the pan. Elos Medtech have been there right from the Per Ingvar Brennermark days. This isn't a new company. It might be new to you, but they have been in this a long time and they truly know. So they're probably older than some of the implant companies, which the question earlier, like, well, what about if the implant companies say it's like, well, they're just nippers. They don't know. We were there at the beginning. They know what they're doing. And they're part of our solution to a big problem. So I did promise you, I'm going to give you something, and we're almost done. I promise we're going to give you something as the future. One thing I would say about digital dentistry at the moment, and you may agree or disagree, is I think it's an absolute mess. It's fragmented, there's little pocketed silos of this doesn't talk to that doesn't work with this. Anybody feel that at the moment? More systems coming out all the time? Heads aching? I've had enough. We need to harmonize and simplify all of this. This is exactly what we got when we went to ELOS. Because my surgeons, one driver for all their scan bodies, for all their different systems, one library system, multiple choices of going tie-based or custom, but it's simple. It's not complex. I'm not going in and out of systems because at its core, we are manufacturers. Dental laboratories are manufacturers. They hate it when I say that in the UK. And we come from this kind of history of manufacturing. So I'm sure you guys in America know who this chap is, Henry Ford. But he was like labs that I used to walk into. And what do I mean by that? Well, we'd buy all the raw materials in and we'd make everything. But we don't do that anymore. We're more like, you know, these are the old guys that were doing that. That's how they were trained. We're more like this. So this is the mini plant in the UK. And what they're actually doing now is they have 4,000 part suppliers. They assemble. That's what modern labs do. I do a lot of design, but my team actually do just assembly and detailing. If I'm, you know, frank about it, that's what we're doing more and more. And this is what a modern lab starts to look like. We've only just moved into this chapel, by the way, so it's got a lot of work to do. So it's an old chapel we've moved into. But we tap into these. So if we do need a highly complex structure doing with the ELOS scan body, Dentsply and Atlantis have partnered with them. Createch accept them. I mean, you know, Vulcan, I don't know which companies are available to you, but it's an open workflow system. So you don't get stuck with having a solution. So the final bit is our future. Has anybody seen this robot, implant robot? So, this isn't the last. There are a lot of money going into this right now. So a robot that can place an implant. What's your first reaction when you hear about robots and automation coming into our industry?
Failing.
Sorry?
Failing.
Failing? Yep. Some of it's fear as well. You know, like we reacted quite badly when early on, we were a bit like, geez, because the message we were getting from the industry was, it's going to take your jobs. No one's going to need you anymore. And that just triggers what they call the chimp in you. That's your first reaction. So this guy, so Professor Steve Peters, he was actually one of the Sky cycling team, you know, like sports psychologists, and he helps people get to that last 5% of, you know, pure performance. And he's saying the worst thing that happens is our chimp is instantly going off and we start to catastrophize, like we're never going to win, the machines are going to do better than us. And in many ways, he's tapping into what we had here. These are the Luddites. Have you heard of the Luddites? So the mills in the UK, when the Industrial Revolution started, the Luddites used to break in and try and break all these mills because it was going to ruin everyone's life. We were all going, you know, to a very dark, horrible place because of these horrible, beastly machines. But actually, the quality of life for everybody continually improved. So had they held that back, we would not have got where we are today. And where they've got it wrong is, you can't fight a machine. You just can't fight a machine. Why can't you fight a machine? It never gets bored. It never gets sick. It never gets tired. It's just going to keep going. But actually, we're looking at it all wrong. We're not here to fight the machines. They are actually going to be our best utilizable tool. So does anybody know about the Condor study with Steve Jobs? Absolutely brilliant. So somebody did a study of locomotion, so the effort it takes for an animal to get from point A to point B. And human beings are the least efficient animal at movement, getting from one place to another. So they did this whole study, and then one of the researchers was like, but let's do something that other animals can't do. We can create things. So they did it again, and they put a human on a bike. Where did we go then? Right to the top. We are the most efficient species because we are inventive and can create it. Steve Jobs said computers are a bicycle for the mind. A computer and new automated tools and everything that's coming will actually help you do much more, but you do it. It's not going to be fighting against you. You will do it. AI is not new. This is Alan Turing. And Alan Turing gave the first lecture on this in 1947 about a sentient computer, a system that could learn for itself. And we've kind of been through this. Do you really know these? It's that first ramp up when everyone's super excited, it's all going to be great. And then that slump because things were breaking, things aren't working as great as they were going to be. But we're actually coming to here now. It's becoming usable. What do I mean by usable? Have you heard of this company, Pearl? Okay, so what Pearl do is they take the scans. They'll then be able to give you an in-depth report on exactly what's going to be going on with those teeth. Why is that important? It's going to change the whole process of what we do. Completely change it for the better. So I said at the beginning, who here likes chairside milling? Anybody like any chairside stuff? Do you like it? Love it. Good man. It's going to be going away soon. Honestly, it is. 5 years, I reckon. I'll show you why, because you're going to have something even better. This is Perceptive. Anybody heard of Perceptive? No? Perceptive have come to the market. They've got a scanner that acquires all of the information. Once it's acquired all of that information, it then goes through to a system and it says exactly what needs to be done to this patient's teeth. So it could be implants, it could be a simple crown like this. Here's where the genius happens. It then produces the crown. So that tooth's not even been prepped. That crown is now ready because it can make a precise path of how it's going to prep it. We do this all the time. Does anybody use split file milling? So you plan two bits, they go together, they always fit. This is exactly the same concept. The only thing that was challenging was even the most skilled surgeon can't make exactly that cut. Well, you don't need to. Plan better, plan for the things that you want to have in. So if it's an implant, it's a crown, it's all there. You've got now all these 7 options and different gingival heights. And then we've got the ideal retention ratio, we've got the ideal emergence profile, everything we need. But who's prepping now? The robot's prepping. The surgeon doesn't prep. So the surgeon sits down the patient and this preps it. And you're like, oh, okay, but when's that going to happen? Now, it's happened. So already, this is the robot prepping that prep. They delivered the first ever crown from this. So that was made in a laboratory. So it's immediacy. You don't need chairside. It's still one visit dentistry, but everything was just sat there waiting for you. No stress on your team, no one having to maintain a machine, stock control, ordering. Huh? The patient can't move because it actually locks onto it. Yeah, I bet. Yeah. How do we know that this is going to be big? Who's one of the investors? Mark Zuckerberg's father, Ed Zuckerberg. There's a lot of money behind this project. It's going to be a thing. And I think that's great because it allows all of the team now to give all of our efforts. We can utilize the HB4 for perfect planning, perfect lab work. Patient comes in, one visit, done. More efficient for the surgeon, everyone wins. It was brought back by a very simple challenge. The guy who invented it is in Canada and he said, look, it's really remote. It's hard to get that access to people. It's hard for them to keep traveling in. So he wanted to make it dead easy. I can relate to him because I said to you before, we're sort of in the middle of nowhere. This is us. You know, look around, there's nothing there. You know what I mean? We're in the middle of nowhere. But we can have state-of-the-art digital workflow and we can sort of provide the best things that we can in a completely different environment. We must all know who Christian Coachman is. Yeah? Look what he said. Dentistry leads lab technicians now more than ever. He's totally right. He then went on to say dental technicians will take over the industry. I believe he's right. So, still focus on these. You still have to be able to know how to do it. I said to you at the beginning, CAD-CAM's a tool. If you don't know how to do it, all the stuff I've shown you is of no use to you. The only sticky note you'll ever see in my lectures, Anne. But look, you know, you've got to have all the knowledge to make the most out of that tool. It's really simple. There is no magic here. You can't be like this lad from Ireland who was asked to strap down the quad so they could take it home. You know, that's just not going to work. And I promised you at the beginning I'd show you the surgeon who was using the best scanner on earth. That he asked me to restore 2 implant crowns. I can see the ELOS scan body, but not a lot else. I mean, come on, guys. Yeah. He sent me that to work on. I was like, come on, can't work. So what we want to do, eliminate all the remakes, the hassle, the issues, lost surgery time. It's got to go away. We've got to make our patients' and surgeons' lives better. That's how you become a valued part of their team. That's when they want to work with you and serve their patients the best they can. Cheap is a false economy. It totally is. For the 60 quid that you think you're going to save on a component, if you lose half an hour chair time, blown it. So, time is the most valuable thing we have and far too precious to waste. And I am glad to say I am finished on time, and thank you for your time.